Hope you all are good and doing well for the preparation of your A2 mathematics. Guys, today the topic what we are going to discuss is about the modulus function, and after that we will discuss about the linear modulus function, graph, and thirdly the solving modulus inequalities. These are three topics what we will try to cater in this lesson. Okay, first of all, before we start this topic, we need to know what is the modulus of a function defines. Like we can say, the modulus definition of, we can write definition, uh, the modulus of a number defines the magnitude of the number but without a sign attached. That means you need to know that this without sign attached means that the modulus of any number, no matter positive or negative, is always always a positive number. For example, and generally, the modulus of x is denoted by, x is any number, is denoted by mod x, and the modulus of a number is also called the absolute value, because it will always be positive. Like we wrote it here, let me select it. Yeah, this is the important key point you need to know. One point, right, and let me highlight it because you need to know this. And denoted by the this is another name is absolute values. Like mathematically, modulus of x can be written as is plus x if x is greater than or equal to 0, and it will be minus x if x is less than 0. Most of the students get confused about this plus and minus modulus. Like for we can do this example. If you replace, for example, I can explain you this definition with example. Let x be, let mod of x is equal to 3 plus 3. So as this 3 number is greater than 0, so we will go with this definition. This definition states it will be 3. And if mod of minus 3, absolute value of minus 3. So if now here you are, minus 3 is less than 0, so x will replace with negative, so you will go with this root, that is plus 3. How plus? Minus, and here minus by default here, and minus x is 3, so it will be again plus 3, right? So here we can see the modulus of any number, this definition, no matter it's positive or negative, is always a positive number. That's proof from here. I hope it is clear. Now before we start solving any modulus function, uh, we need to know two properties of the modulus. The first property, I can say that property 1, property 1 states that if you have modulus x equal to k, states if modulus of x is k, then you can write it x equal to plus k or x is equal to minus k. And these two signs, I will explain you while solving the question, that we get from this modulus, because in the modulus we have both positive negative, but result is negative as we did in the definition. So this is property 1, and like you can take the example along with it. Example of this property: suppose you have modulus function x equal to 2. So what comes? The result. As this is equality, so you can place the plus minus on any side, it doesn't affect. But while doing the inequalities, we need to be careful about the sign. So generally I will go with one pattern. So modulus mean plus minus x is equal to 2. So here it means x plus x equal to 2 or minus x equal to 2. That comes to be x is equal to minus 2. So we have two results here. One is x is 2 plus 2 and x is minus 2. And while the property 2 states property number 2, if mod of x equal to if you have two mod, like in place of x we can say generally a is equal to mod b. If you have mod a equal to mod b, either side of equality, if you have mod, then if you take the square on both sides, so mod of a equal to mod of b, so this is equivalent to a square equal to b square. Again, you can take the mod out of the you can take the square out of the mod, okay, and you can operate it now normally algebraic method, by using algebraic method. So these are the two properties, right? We can also state that if you have like if there is mod of a square minus mod of b square, then it will be equivalent to applying the identity a square minus b square mod a one time plus one time minus. Meaning either you can write it as or this can be written as a square minus b square by using second property, and that will equivalent to a plus b and a minus b. In either case you get the same result. Let's see how to use these properties, two properties, in the question. Now guys, I will discuss three cases of solving modulus function. The case 1, that is whenever you have modulus function, like you can say you have 2x minus 1 equal to say 3. Yani the case 1 says we have one side of equality, we have modulus function equal to some constant, then how to proceed? So as it's clear from the definition that this modulus can be written as with plus and minus. So plus minus, we can write, remove the post modulus, equal to 3. Now you have two options to solve this. The question can be solved. Okay, either we have 2x minus 1 equal to 3 positively, or we have negatively 2x minus 1 equal to 3. Because of the modulus, we know we have we can use the property 1 to write it in this form. So no matter, you can directly write plus minus with 3 here. Because of equality, it doesn't affect, but in case of inequality it will affect. So that's why I'm going to keep a one pattern, that once you open the modulus, put the plus minus with the variable. So here we can solve it algebraically. We get 2x equal to 1 goes to the side to become plus 1, 4, so x will be 2, and here minus 2x plus 1 equal to 3, so minus 2x equal to 1 plus goes 1, this goes other side, so minus 1, so it will be 2, divided by minus 2, will get minus 1. So these are two results what we get for solving this modulus. But here don't finish your answer. For every modulus question, you guys to make a check before finalizing your result, that either your answer is justifying the given inequality. For this, whatever the solution you will get, must put it in the original function. So here original function is 2x minus 1 equal to 3. So now we'll replace 1 by 1 the values of x. We got x is 2 here, like it will be 2 times 2 is 4 minus 1 equal to 3. So mod of 3 equal to 3, and we know that it is 3. It will be 3. Leave a left hand side equal to right hand side. So this is one of our solution. And so for other solution, x is equal to minus 1. So in the same function, we'll get 2 times minus 1 is minus 2, and minus 1 equal to 3. So it's minus 3 mod equal to 3. So as we know that this become plus 3 out of mod, because it's absolute value. So your left hand side equal to your right hand side. So final solution is x equal to 2 or x is equal to minus 1. So this is how we can solve. I hope it is clear. Let's proceed to second question. Okay guys, now we are going to discuss about case 2. In such cases, you have modulus function and at one side of equality and a non-modulus function on other side. This is a case study for the solution of modulus with non-modulus function. So how to solve this? In such case, we have two options. Either we can apply the property number 1 or property number 2. So let's start with the property 1 first. As we know, this side is modulus, so it will plus minus out of modulus x minus 4 equal to 2x plus 1. So we have two options, either x minus 4 equal to 2x plus 1, or we have x minus 4 with a minus equal to 2x plus 1. One with positive, one with negative, and just solve algebraically. Bring all the x one side. So once this moves here, it becomes x minus 2x is minus x, and 4 goes other side, become minus becomes plus, so it will be 5. So x will be minus 5, or here minus x plus 4 equal to 2x plus 1. So x moves this side and 4 goes other side. It's minus 3x equal to minus 3. So x will be 1. Right? Now these are the two solutions what we get algebraically. Now before finalizing our answer, we must check our results with the original function. For this case, original function is x minus 4 modulus is equal to 2x plus 1. So 1 by 1 for x equal to minus 5. So we'll get minus 5 minus 4 equal to 2 times of minus 5 plus 4. It's minus 9 absolute is equal to minus 10 plus 1. So it becomes 9 and it becomes minus 9. That are not equal. So minus 5 will not be the part of our solution, final solution, right? So we will reject this operation. And for second case, for other solution for x is equal to 1. Here in the original we will see 1 minus 4 equal to 2 times of 1 plus 1. So minus 3 modulus is equal to 2 1 2 plus 1 3. So 3 equal to 3. So here left hand side equal to right hand side. So we can say the final solution for the given function is x is equal to 1, and we will reject x is equal to minus 5. So that is the final answer. I hope you understood. Okay, now we are going to discuss the case 3. Here we have two modulus function on either side of the equality without any plus or minus, right? Out of the modulus, plus minus out of the modulus, it means there is no one. So single modulus function one side of equality and single modulus function on other side. So in such case we recommend you to go with the property 2. So that states take square on both sides. So we'll get 3x plus 4 modulus square and x plus 5 modulus square. Now property states modulus, if modulus square a equal to modulus b square, then it will be a square equal to b square. So this is the property 2 and we can apply it here. So it will be 3x plus 4 whole square equal to x plus 5 whole square. So now applying the simple basic identity that a plus b whole square, that was a square plus 2ab plus b square. I'm applying it here. It becomes 9x square plus 24x plus 16 equal to x square plus 10x plus 25. Now simplify algebraically, bring every right hand side towards the left. So we get 8x square plus 14x minus 9 equal to 0. Right? Now this is the quadratic function. So here we can solve this by applying midterm break rule, if possible, converting square for quadratic formula, right? Any method which is easy and convenient for you, you can apply to solve this. So here I'm going to apply the midterm break rule, and that gives me 2x minus 1 times 4x plus 9 equal to 0. So simplified, x 2x minus 1 equal to 0 once, so x will be 1 by 2, or other is 4x plus 9 equal to 0, mean x is equal to minus 9 by 4. These are two solutions we get while solving this inequality case. And again, don't forget to check your results, and for check we always apply for the original function. So here for x equal to 1 by 2, and for x equal to minus 9 by 4, 1 by 1 we will apply. Yes, let's see how. So in the original function x 1 by 2, we get 3 by 2 plus 4 modulus equal to 1 by 2 plus 5, 8 plus 3 is 11 by 2 modulus equal to, it will be 10 plus 1, 11 by 2. So 11 by 2 equal to 11 by 2. So this is one of our true solution, that it is true. And similarly for others, minus 9 by 4, 3 times minus 9 is minus 27 by 4 plus 4 equal to minus 9 by 4 plus 5. So 16, and we'll get 11 by 4 equal to 20 and 11 by 4. Yes, this is 11 by 4 equal to 11 by 4. Again your left hand side comes to be right hand side, so another true value. Final solution is x is equal to 1 by 2 and x is equal to minus 9 by 4. These are the answers. I hope it is clear. Now for the case 4, guys, you can see this is kind of question which we have two modulus of both side of equality, and but along with some addition or subtraction of with constant. So in such cases we have two methods. Either we can expand the modulus 1 by 1, and we can make two equations, and that gives us the 4 answers, and finally with the help of check we can get the final answers. But if you can apply, because these are the linear functions here inside the modulus, if we prefer to go with the property number 2 to expand it, so taking square on both sides, we have like this x plus 3 mod square here, and here we have the two functions together mod square. So here it will be x plus 3 square, and here identity a minus b whole square. A minus b whole square, we know that that is a square minus 2ab plus b square, right? We can apply this identity to solve it. So a square means 10 square means 100 minus 2 times 20 ab plus b square, x plus 5 mod square. So, and we know that mod of square is equal to the square of the function without mod. Okay, we are applying here. So x plus 3 whole square equal to 100 minus 20 into x, not into, it's mod of 20 times x plus 5 mod plus, and this can be written as without mod whole square. Okay, now apply here a plus b whole square, x square plus 6x plus 9 equal to 100 minus 20 times x plus 5 mod plus, again applying x square plus 10x plus 25. Now what to do? Separate the mod function one side and the other on other side. Like I'm shifting this because of minus, I'm shifting this on the left hand side, and rest of everything from left towards the right hand side. We'll get 20 times plus 20 times modulus of x plus 5 equal to 100 plus x square plus 10x plus 25 and minus, now shifting the left hand side, minus x square minus 6x minus 9. So you can see few things will be cancelled and simplified. We get 20 times x plus 5 modulus equal to 125 minus 9, we get 116 plus 4x, right? Because 10x minus 6x is 4x, right here. So even we can take further simplification. 4 to the 8, 4 9 36 plus x equal to 20 times x plus 5. So further we can divide by 4, we get it 5 times x plus 5 mod equal to 20 plus x. Now this is the case study as we did here, case number 2. One side of equality we have modulus and other we don't have modulus, non-modulus function, right? So same case, we have one side modulus function and other side we have non-modulus function like 29 plus x. So we can apply this even property once plus minus, or again we can take square, it doesn't affect. So if I can go with the plus minus 5 times x plus 5 equal to 29 plus x, or we can write it as plus minus 5x plus 25 29 plus x. So we can solve it once with positive equal to 29 plus x, or with a negative equal to 29 plus x. So 5x, and this takes x one side, 29 minus 25, we get 4x equal to 4, so x comes to be 1. And the second option, you can see here minus 5x minus 25 equal to 29 plus x, so minus 6x is equal to 54 with the minus plus 54 29 plus 25, so x will be 6 9 is 54 minus 9. So we have two results here with this, but before finalizing your answer we must make a check like this. For the original function, that was x plus 3 equal to 10 minus x plus 5. So here one by one, for x equal to 1 we have 1 plus 3, 10 minus 1 plus 5 is 4 modulus is equal to 10 minus 6 modulus, 4 equal to 10 minus 6, then 4 is equal to 4. So your left hand side equal to your right hand side, so x equal to 1 is the one of the true solution for the given question. Also we need to proceed for the same with other, for x is equal to minus 9. So we'll see any minus 9 plus 3 equal to 10 minus 9 plus 5, it's minus 6 equal to 10 minus and minus 4, it becomes 6, 10 minus, and this modulus become plus 4. Yes, so another solution for the given function is x equal to minus 9. Final solution are x is equal to 1 and x is equal to minus 9. I hope it is clear.